Okay, so our second video is the should and could do part of completing the square. With the must do part, you'll notice that all of your a values are 1 and all of your b values are even, which makes it easy to take half of b because you'll keep a nice number. What I'd like you to be able to do with your should do is deal with fractions. Like for this one, with x squared plus 5x minus 3 equals 0, your b value is odd, so you're going to get a fraction, and that's okay. It's not required at this point, and that's why it's a should do, but you can all handle it, so I would really like you to try. So again, the process for completing the square says first remove the c term out of the way. So we're going to add 3 to both sides and get x squared plus 5x equals 3. Step 2 is make your b list. So here I have b is 5. Half b is 5 over 2. Because think about half b also means b over 2, 1b over 2. Okay, leave these fractions alone. Do not convert to decimal. You'll get yourself in trouble. This all works itself out in the end, so don't panic with the fractions. And now half b all squared, when you square a fraction, you square both parts. 5 squared is 25, 2 squared is 4. Okay, so we added c to both sides to get it alone. We made our b list. Step 3, add half b squared to both sides. So here I'm going to have x squared plus 5x plus 25 fourths equals 3 plus 25 fourths. All right, this is now a perfect square. Who knew until today that I could have something not factorable and kind of ugly looking with fractions and odd numbers that's a perfect square? But it is. And that's part of our math is consistent. That's part of our discovering patterns, is that with nice numbers we always put half b in parentheses. Well, same here. So now I have x plus 5 halves all squared, that's my perfect square trinomial, equals, and I need to clean up 3 plus 25 fourths. Well, 3 is 12 fourths. So really this is 12 fourths plus 25 fourths, or 37 fourths. Okay, again, leave your fractions alone, leave them improper, because it's going to work itself out in the end. Okay, now our last step is to solve, and we solve as usual. We undo squaring by square rooting. So when I square root this side, the squared goes away, and I'm left with x plus 5 halves, and that equals the plus or minus square root of 37 over 4. Okay, well, 2 more steps and we're done in our solving. We subtract 5 halves from both sides to get x alone. So I have x equals negative 5 halves, plus or minus. Now I cannot square root 37, so that stays put. And the square root of 4 is 2. And you're done. Okay, so you're going to get maybe uglier answers because of the fractions. This should look familiar to you, though. When you solved with the quadratic formula, you got answers that looked like negative 5 plus or minus the square root of 37 all over 2. That's equivalent. Okay, so they're the same thing. It's just with completing the square, we get an answer more like this. And we need to get really good at completing the square for a lot of reasons. So keep practicing. Okay, our last example is a could do example. And again, this has an added twist in that my leading coefficient, my a value, is not 1. And in order to complete the square, a has to be 1. That's huge. So the first thing I need to do then is make it 1, and you make it 1 by division. I'm going to divide by 2, but if I divide that by 2, I need to keep the balance and divide every piece by 2. So now I have x squared minus 1/2 x minus 2 equals 0. Once I've gotten a to be 1, now I can go through the 5 steps. So here we go. We're going to get c out of the way. X squared minus 1/2 x, add 2, equals 2. Make our b list. B is negative 1/2. Half of negative 1/2, half of b, is negative 1/4. 1 times 1 is 1, 2 times 2 is 4. It's just multiplication straight across. And half b all squared, negative 1/4 squared, well, When you square a negative, you get a positive. 1 squared is 1, 4 squared is 16. Add half b squared to both sides. X squared minus 1/2 x plus 16 equals 1/16 plus 1/16. This is a perfect square. There's your b term, x minus 1/4 all squared equals 2 1/16 is 33/16. 2 is 32/16 plus 1 33/16. Okay, solve square root and you get x minus 1/4 is the positive or negative square root of 33/16. Add 1/4 to both sides. So x is 1/4 plus or minus. I don't know the square root of 33, I leave it alone. Square root of 16 is 4. And you're done. So again, for should and could, the process is no different. It's just a couple of things to be aware of. Be aware that you will get fractions when b is odd. Be aware that a has to be 1 before you can start completing the square. And that's it. Have a great night.